Hi, I want to talk about trucks, and we're going to talk about reverse kingpin trucks and channel trucks just to clear some assumptions. So on a regular reverse kingpin truck, we have this setup. We have a negative caster in the front and we have a positive caster in the back. Out of the two, the negative caster is the more stable, and then we have the less stable caster on the back. I want to look here in the front to see how this thing actually is restrained. We have a rotational axis that goes from the pivot cup all the way to the kingpin in this direction. So it allows only rotation around that axis. And then we have the bushings, which allow a little bit of rake. But as you can see, there's not that much space. Everything is held in just one point. Now on electric skateboarding, we have mostly on the back the motors. Now, of the two positions of the trucks, this is the less stable, and this is where we have decided to put the motors. The motor will introduce unwanted vibrations due to the ERPMs. Our ESCs, they don't produce identical outputs, so one motor will try to go faster than the other and will produce vibrations. Again, we got the rotational axis going in this direction, and on the back we have the less stable system compound with the introduction of unwanted vibrations by the motors. That is on a regular board. Now let's go to the channel trucks. On the channel trucks, we have on the back we have a trailing caster. So we have a negative caster on the back, which is the more stable. And then let's go again by the same point. We got the rotational axis runs along the center of the kingpin. So everything will rotate along the center of the kingpin, from this tip of the kingpin to this one. That will be an axis of rotation. That means that the hanger can just rotate around that point. Well, you have this plane, I cannot show it better. So it's just gonna rotate around here, this way or that way. Now, as you can see, different from a reverse kingpin, that it just have that point of constraint, we have the springs. So the springs are placed a distance away from the center of rotation. These allowed for having better control on the vibrations produced here. So even though we are in the most favorable position of the truck, which is a trailing caster, on top of that we have a leverage arm from the springs to the center of rotation, from the spring to the center of rotation, in order to have more stability. And we have the motors installed in the most favorable position, which is a trailing caster. Again, it just reduces the vibration of the overall system, and you have more leverage to control any unwanted vibration that might come up. Now we go to the front, and this is where all the fuss has been about, because it is a leading caster, it's a positive caster, and people think it's less stable. That's just nonsense, and it's just a lack of actual hands on the equipment. It's just assumptions. Now again, we have a rotation axis in the front, so it means each rotation is gonna go around that point. Again, we have a distance from the spring to the center of rotation, which allow for more control. And once more, the deck acts like a rake. It has a little bit of rake here because the deck is part of the system too. So as you can see, it's just a different system. There's more control, even though we can actually tighten each spring to make it more comfortable for us. And there's more control of any vibration that can come up in this position, even though it is the less stable position of the two. But there's more points of constraint where we can actually minimize the vibration in the front render just the negative effect of having a positive caster in the front, just renders that thing neutral. So it is as stable as it can be. Now, difference on the system. We're running pneumatic wheels, we're running way taller. The center of gravity will be way taller. Now, that's where the rider comes into play. The rider needs to be aware that is running on a higher system, in a taller center of gravity, and that the deck itself stores energy. So whenever you jump, whenever you vibrate on this system, the deck's gonna take that energy and then pop it back. That's where most of the experienced riders have been having issues, because they try to floor it all the way, they used to a stiff deck, and suddenly your deck turns into a Vanguard trying to do 40 miles per hour, and then you pay the price. So it's not a truck issue. The truck is pretty stable. It has all the benefits of added leverage arms, has all the benefits of having a rake, it has all the benefits of having proper control. It is just a different system. Stable at high speed with proper pneumatic wheels. And when it comes to electric, I decided to go this way because all the unwanted vibration from the motors are properly contained on a negative caster on the back, which is awesome. Well, I hope I have cleared some stuff with that. So it's just different. They're just different, people.